Good morning. Today we are going to discuss about virtualization in cloud computing. First of all, what is virtualization? Virtualization is a technology that allows a single physical machine be divided into multiple virtual machines. Each virtual machine acts as an independent machine. Virtualization is done by using software known as hypervisor. The figure shows hardware, hypervisor and virtual machines. Hypervisor is applied on hardware to create multiple virtual hardware units. Hardware may be a computer, storage or a network. We can create multiple virtual computers using a single computer. We can create multiple virtual storage units from single storage unit. We can create multiple virtual networks from a single network. Actually, physical hardware is treated as host. The virtual or logical units created by hypervisor are called guest units or virtual machines. Assume that we have a computer. To execute a program on a computer, we need to install operating system, required compilers, its libraries. Then we can write a program, we can compile the program and we can run the program. Now observe the diagram. There is a host system. Assume that it is a computer. Operating system is loaded. Hypervisor is applied to create multiple virtual machines. Each virtual machine acts as independent computer. Means every virtual machine has a separate operating system, compilers, libraries and its applications. For example, virtual machine 1, first virtual machine may contain Windows operating system, another virtual machine may contain Unix operating system, etc. Every virtual machine may contain a different operating system. Every virtual machine may use to solve a different application by the needs of different users. Nowadays, we are using high performance computers and laptops. While we are working on these systems, the applications may use only part of its computing capacity. For example, a particular application using 40% of computing resources, remaining 60% of computing resources becomes idle. Virtualization solves this by allowing one physical server or computer to host multiple virtual computers, each running its own operating system and apps. Each virtual machine acts as an independent isolated machine so that we can have a better utilization of IT resources instead of keeping them idle. We should know what is the need for virtualization. The following 5 points describes the need for virtualization. The first one is increased performance and computing power. Second one, underutilized hardware and software resources. Third one, lack of space. Fourth one, greening initiatives or eco-friendly initiative. Fifth one, rise of administrative costs. Let us discuss all these points one by one. The first one, increased performance and computing power. Nowadays, the average end user desktop is powerful enough to fulfill all the needs of everyday computing, and there is an extra capacity that is rarely used. Almost all of these PCs have resources enough to host a virtual machine. The same consideration applies to a high-end computer where supercomputers can provide an immense computing power that can accommodate the execution of hundreds and thousands of virtual machines. The second one is underutilized hardware and software resources. Hardware and software underutilization is occurring due to increased performance and computing capacity, limited or occasional use of resources. Computers today are so powerful that in most cases only a fraction of their capacity is used by an application or the system. Moreover, if we consider the IT infrastructure of an enterprise, many computers are only or partially utilized, whereas they could be used without interruption on a 24 by 7 or by 365 basis. For example, desktop PCs mostly devoted to office automation tasks and used by administrative staff are only used during working hours, remaining completely unused overnight. Using these resources for other purposes after working hours could improve the efficiency of IT infrastructure. To transparently provide such a service, it would be necessary to deploy a completely separate environment which can be achieved through virtualization. Third one is lack of space. The continuous need for additional capacity, whether storage or computing power, makes data centers grow quickly. Companies such as Google and Microsoft expand their infrastructure by building data centers as large as football fields that are able to host thousands of nodes. Although this is viable for IT giants, in most cases, enterprises cannot afford to build another data center to accommodate additional resource capacity. This condition, along with hardware underutilization, has led to the discussion of a technique called server consolidation, for which virtualization technologies are fundamental. Fourth one is greening initiatives or eco-friendly initiative. Recently, companies are increasingly looking for ways to reduce the amount of energy they consume and to reduce their carbon footprint. Data centers are one of the major power consumers. They contribute consistently to the impact that a company has on the environment. Maintaining a data center operation not only involves keeping servers on, but a great deal of energy is also consuming in keeping them cool. Infrastructures for cooling have a significant impact on the carbon footprint of a data center. Hence, reducing number of servers through server consolidation will definitely reduce the impact of cooling and power consumption of a data center. Virtualization technologies can provide an efficient way of consolidating servers. Fifth one is rise of administrative costs. Power consumption and cooling costs have now become higher than the cost of IT equipment. Moreover, the increased demand for additional capacity, which translates into more servers in a data center, is also responsible for a significant increment in administrative costs. Computers, in particular servers, do not operate all on their own, but they require care and feeding from server administrators. Common system administration tasks include hardware monitoring, defective hardware replacement, server setup and updates, server resources monitoring, and backups. These are labor intensive operations, and the higher number of servers that have to be managed, the higher the administrative costs. Virtualization helps reduce the number of required servers for a given workload, thus reducing the cost of administrative personnel. Major components of virtualization. Virtualization is a broad concept that refers to the creation of a virtual version of hardware or software environment or storage or a network. In a virtualized environment, there are three major components: guest, host, virtualization layer. Guest. The guest represents the system component that interacts with virtualization layer rather than with the host as would normally happen. Guests usually consist of one or more virtual disk files and a virtual machine definition file. Virtual machines are centrally managed by a host application and sees that manages each virtual machine as a different application. Host. The host represents the original environment where the guest is supposed to be managed. Each guest runs on the host using shared resources. The operating system works as a host and manages the physical resource management and the device support. Virtualization layer. The virtualization layer is responsible for recreating the same or a different environment where the guest will operate. It is an additional layer between network and storage hardware, computing, and application running on it. Usually, it helps to run a single operating system per machine, which can be very inflexible compared to the use of virtualization. Characteristics of virtualized environments. The virtual environments are created by means of a software program which is called hypervisor. The common characteristics of virtualized environments are increased security, managed execution, portability. In managed execution, again there are sharing, aggregation, emulation, isolation. Let us discuss about the first one, increased security. The ability to control the execution of a guest program in a completely transparent manner opens new possibilities for delivering a secure, controlled execution environment. All the operations of the guests are generally performed against the virtual machine, which then translates and applies them to the host. A virtual machine manager can control and filter the activity of guest programs, thus preventing some harmful operations from being performed. Resources exposed by the host can then be hidden or simply protected from the guest. Increased security is a requirement when dealing with untrusted code. Then managed execution. Along with increased security, the virtualization implements features like sharing, aggregation, emulation, and isolation. Sharing. Virtualization allows the creation of a separate computing environment within the same host. Virtualization may create many virtual environments in the same host. Many users can share the same host. This basic feature is used to reduce the number of active servers and limit power consumption. See the figure. A system is shared into so many virtual systems. Next one, aggregation. Virtualization allows sharing of physical resources among several guests. Virtualization also allows aggregation, which is the opposite process of sharing. See the second image, aggregation. So many systems are made together to form one system. So we are aggregating many systems into a single system. Sharing is a single system is sharing its resources to many virtual machines, but aggregation is combining many systems into a single system. A group of separate hosts can be tied together and represented to guests as a single virtual host. This functionality is implemented with cluster management software, which harnesses the physical resources of homogeneous group of machines and represents them as a single resource. Then third one is emulation. Guests are executed within an environment that is controlled by virtualization layer. Execution environment of guest is controlled and tuned by virtualization layer. The guest environment need not be the same kind of environment as a host. For instance, a completely different environment with respect to host can be emulated, thus allowing the execution of guest programs requiring specific characteristics that are not present in the physical host. Isolation. Virtual machines acts as independent and separate machines. Every virtual machine has its own resources. They are not interdependent. Virtual machine manager controls the operations of virtual machines. If one virtual machine crashes, it will not affect other virtual machines. Then portability. Portability in virtualization means virtual machines or containers as self-contained images can be easily moved between different physical servers or environments, allowing for seamless migration, load balancing, testing, and robust disaster recovery without major reconfiguration, decoupling applications from specific hardware. This characteristic enables efficient resource utilization, quick deployment, and enhanced business continuity by treating servers as flexible mobile files. So virtual machines can be moved from one physical server to another physical server. So which is said to be portability. Executing a program on any computer is said to be portability of a program. Executing a program on any environment is said to be portability. The same fashion, virtual machines also can be moved from one server to another server, which is said to be virtual machine portability. The portability characteristic can be explained clearly with the help of the figure shown in here. See the diagram. Before migration, there are two servers, server A and server B. Server A is divided into 4 virtual machines. Server B is divided into 2 virtual machines. Virtual machines are portable. That is, virtual machines can migrate from one server to another server to consolidate servers. The virtual machines of server B are migrated to server A to consolidate server A. See the diagram after migration. The server A contains 6 virtual machines and server B contains 0 virtual machines. So, virtual machines are portable. Virtual machines are portable and it helps consolidating servers. Taxonomy of virtualization techniques. Taxonomy is classification of virtualization techniques. Virtualization techniques are classified based on the resources being virtualized. The resources that can be virtualized are computers or servers, storage units, and network units. Computers can be virtualized into many virtual machines. Storages can be virtualized as many virtual storage units. Networking can be virtualized as many networking units. Virtualization is mainly used to emulate the execution environment to create multiple virtual computers. So, we discuss virtualization of execution unit here. Again, there are two different levels of virtualization in execution unit. One is process level, the other is system level. Process level is also known as application level virtualization. This process level virtualization is again divided into 3 virtualization techniques: emulation, high level language virtualization machine, and multi-programming virtualization. System level virtualization is divided into 4 virtualization techniques: hardware assisted virtualization, full virtualization, para-virtualization, and partial virtualization. We'll discuss each and every one in detail. Let us see the next figure. Taxonomy of virtualization is classification of virtualized environment. So virtualization is classified into 3 kinds of virtualization: execution environment virtualization, storage virtualization, network virtualization. We discuss more about execution environment virtualization. So it is again classified into 2 levels: process level virtualization, system level virtualization. Process level virtualization is classified into 3: emulation, high level language virtual machine, multi-programming virtualization. System level virtualization is classified into four groups: hardware assisted virtualization, full virtualization, para-virtualization, and partial virtualization. We'll discuss about each and every virtualization environment in the next slides. This also the extension of the previous slide, where virtualization is divided into three: execution environment, storage, network. Execution environment is divided into process level virtualization, system level virtualization. Process level virtualization is divided into three: emulation, high level language virtual machine, multi-programming virtual machines. System level is divided into four: hardware virtualization, hardware assisted virtualization, full virtualization, para-virtualization, partial virtualization. We will discuss about each and every virtualization technique in detail in the next slides. Machine reference model. Let us consider a normal desktop or laptop. To perform operations on a general digital computer, that is computer, which contains hardware, operating system is loaded, programming language compilers will be loaded along with its libraries, then we can write programs or applications. See the diagram. It contains hardware, operating system, libraries and applications. There are interfaces. Interface between hardware and operating system, interface between operating system and libraries, and interface between libraries and applications. The interface between hardware and operating system is ISA, Instruction Set Architecture. The interface between operating system and libraries is ABI, Application Binary Interface. The interface between libraries and applications is Application Programming Interface. So whatever the program we try to perform will perform its task or operation based on these three kinds of instructions: instruction set architecture, application binary interface and application programming interface. Security rings and privilege modes. In the previous slide, we have discussed about the operation of a computer through application programming interface, application binary interface and instruction set architecture. These three instructions forms four security rings and privilege modes. The security rings are ring 0, ring 1, ring 2, ring 3. Ring 0 is used for most privileged instructions. Ring 3 is used for least privileged instructions. Ring 1 and ring 2 are used for privileged instructions. Normally, operating system kernel forms ring 0. Ring 1, ring 2 are used for operating system services. Ring 3 is used for user applications. The diagram shows the security rings of a digital computer. For any operation, it uses instruction set architecture, application binary interface and application programming interface. These three forms four rings and four security rings or privilege modes. Hypervisors. The fundamental element of hardware virtualization is hypervisor or virtual machine manager. Hypervisor is a software which divides a physical machine into multiple virtual machines. There are two types of hypervisors. They are type 1 hypervisor and type 2 hypervisor. Observe the figure. The hypervisor that is applied on direct hardware is called type 1 hypervisor, which is said to be system level virtualization. The hypervisor applied on hardware loaded with operating system is called type 2 hypervisor. This kind of virtualization is said to be process level virtualization. Type 1 hypervisor is used for system level virtualization. Type 2 hypervisor is used for process level or application level virtualization. From the taxonomy of virtualization, execution environment is classified into system level virtualization and process level virtualization. Here comes the solution. Type 1 hypervisor is used for system level virtualization and type 2 hypervisor is used for process level virtualization or application level virtualization. In the previous slide, we have discussed about process level virtualization and system level virtualization. In a digital computer or in a virtual machine, whatever the processing we perform, the execution is done through the three kinds of instructions. They are instruction set architecture, application binary interface, application programming interface. Let us consider type 2 hypervisor virtualization from the figure, where it contains hardware, operating system, virtual machine manager or hypervisor, then virtual machines. See the interfaces. The interface between hardware and operating system is instruction set architecture. The interface between operating system and virtualization machine, again virtualization machine is also software. Interface between software and software is application binary interface. Next is interface between virtual machine manager and virtual machines. Virtual machine manager is a software, virtual machine we consider virtual hardware. So hardware and software. The interface between hardware and software is again instruction set architecture. The same fashion, see figure 8b. Type 1 hypervisor virtualization, system level virtualization. There are interfaces between hardware and hypervisor, hypervisor and virtual machines, hardware and software. Virtual machine is software, hardware is computer. So the interface between hardware and virtual machine is instruction set architecture. Next, let us see the next interface, virtual machine and virtual machine manager. Virtual machine manager is considered as software and virtual machine is considered as hardware. So hardware and software, the interface between hardware and software is again instruction set architecture. So in process level there are three interfaces. In system level there are two interfaces. The interfaces are communicated through the instructions shown as instruction set architecture or instruction set architecture, application binary interface, etc. Process level virtualization. The process level virtualization will be created with the help of type 2 hypervisor. There are three classes in process level virtualization. They are emulation, high level language virtualization, multi-programming. Let us discuss about emulation first. Emulation is recreation of same kind of execution environment or a different kind of execution environment. Generally, computer is divided into many virtual computers. Computer is one kind of execution environment. Virtual computer is another kind of execution environment. Next, high level language virtualization. High level language virtual machine means a high level language compiler is loaded in virtual machine to perform applications related to the high level language compiler. The high level language compiler that is loaded in the virtual machine. For example, if you load Java software in virtual machine, you can perform applications in Java language only. If you load C compiler, you can perform applications in C language only, etc. Then multi-programming. Multi-programming means storing more than one programs in the same memory. Multi-programming is a form of process level virtualization where the operating system creates the illusion that each concurrently running application has a complete dedicated machine to itself. This technique enhances CPU utilization. System level virtualization. System level virtualization is done by type 1 hypervisor. The system level virtualization is divided into four types: hardware assisted virtualization, para-virtualization, full virtualization, and partial virtualization. Now we are discussing about hardware assisted virtualization. We know that hypervisor is a software which is used to divide one machine into many virtual machines. If we use hypervisor along with the assistance of some hardware like Intel VTX or AMD V to create virtual machines, this process is said to be hardware assisted virtualization. Full virtualization. Full virtualization is a virtualization technique that simulates entire physical computer into multiple virtual machines. These virtual machines can run independently. Every virtual machine has its own operating system, compilers, and user applications. In this approach, the guest operating system is unaware that it is running in a virtualized environment because the virtual machine acts as an independent isolated computer. The virtual machine directly executes its user applications with the help of physical hardware without the interference of virtual machine manager. See the figure. Type 1 hypervisor is applied to create virtual machines. Every virtual machine contains guest operating system, libraries, and applications. The virtual machines performs or executes its programs using certain instructions. These instructions are instruction set architecture, application binary interface, application programming interface. All these instructions forms 4 security rings. The hypervisor software forms security ring 0, the most privileged mode. The guest operating system forms security ring 1, the privileged mode, and the user applications forms security ring 3, the least privileged mode. In full virtualization, the virtual machine executes its operations such that the guest operating system is unaware of the virtualization. The virtual machines directly communicate with physical hardware without the help of virtual machine manager. Para-Virtualization. Para-Virtualization is a virtualization technique that simulates physical computer into multiple computers. Every virtual machine contains guest operating system, libraries, and user applications. Unlike in full virtualization, the para-virtualization contains modified guest operating system. In a para-virtualization, the virtual machine executes its applications via virtual machine manager. The guest operating system knows that the user executes applications on a virtual machine. The execution is done through virtual machine manager or hypervisor. So, the guest operating system is modified as modified guest operating system. Here also, the execution of user applications performed through instruction set architecture, application binary interface, application programming interface. These 3 sets of instructions forms 4 security rings and privilege modes. Hypervisor or virtual machine manager forms security ring 0, the most privileged mode. Modified guest operating system forms security ring 1 and privileged mode. The user applications forms security ring 3, the least privileged mode. The diagram shows the difference between para-virtualization and full virtualization. In para-virtualization, user application communicates with modified guest operating system. The modified guest operating system communicates with hypervisor. The hypervisor communicates with hardware. Whereas in full virtualization, the user application communicates with guest operating system. The guest operating system directly communicates with hardware to perform the application. This is the difference between para-virtualization and full virtualization. And coming to partial virtualization. In partial virtualization, only part of resources of the physical computer are used to create virtual machines. Instead of considering all the resources, it considers only specific resources of physical hardware of the physical computer to create virtual machines. So, it is called partial virtualization. Virtualization and cloud computing. Virtualization and cloud computing are not same. Virtualization is a technique used in cloud computing to create virtual machines with specific configurations. Every virtual machine will have its own configuration. Every computer will have some configuration. In the same way, every virtual machine also will have its own configuration. Virtualization is a technique to create configured virtual machines, customized virtual machines with security and isolation property. Virtual machines acts as independent isolated machines. Cloud computing means performing computation in the servers available in cloud with the help of internet. In cloud, single server can be divided into multiple virtual servers and each virtual server can be assigned to a different user through internet so that many users work on the same server with the help of virtual machines. Pros and cons of virtualization. First, let us discuss about the advantages of using virtualization. Cost savings, improved hardware utilization, scalability and flexibility, disaster recovery, rapid deployment, isolation, testing and development. First, let us discuss the advantages one by one. The first advantage is cost savings. A single machine can be divided into many virtual computers and many users can execute their applications simultaneously on this single computer. This feature helps the users to avoid purchasing many machines as there is a possibility of creating many virtual machines. So, virtualization helps in reducing the cost of investing on hardware. The second advantage is improved hardware utilization. Before virtualization, while performing applications on computer, some of the computing resources becomes idle as only part of resources are sufficient to perform the task. With the help of virtualization, we are able to run many applications on the same computing resources simultaneously, which improves the utilization of hardware resources. In other way, many systems can be combined to form a single server and can use to run applications. In both ways, we can improve utilization of hardware resources. Next advantage is scalability and flexibility. The configuration of virtual machine can be increased by adding more computing resources, which is said to be scaling up. The configuration of virtual machine can be reduced by releasing some of the computing resources from the virtual machine. This is said to be scaling down. There is a flexibility in scaling up or scaling down the configuration of virtual machines as per the on-demand needs of users. Next advantage is disaster recovery. We can create backup virtual machine easily from a virtual machine. We can move or migrate virtual machine from one server to another server. So, recovery of virtual machine can be done easily during the period of disaster. Rapid deployment. We can quickly create virtual machines and can assign to users. Next advantage is isolation. Virtual machines acts as isolated independent machines. They are isolated from one another. Isolated environment prevents issues in one virtual machine from affecting other virtual machines. If one virtual machine is damaged, other virtual machine will run as usual. Next advantage is testing and development. Virtual machines create isolated environments. Isolated sandbox environments are used to test softwares without impacting other virtual machines or main system. Sandbox environment is an isolated environment used to test the software without impacting the production systems. Next is disadvantages of virtualization. The first disadvantage is high initial costs. Initially, we need to invest on powerful servers and licensing of hypervisor software. The next disadvantage is complexity. Adding additional layer to IT stack automatically requires specialized skills for management, monitoring and security. Adding virtual machine manager layer creates complexity. So here we are going to use virtual machine manager to create number of virtual machines. Managing more number of virtual machines automatically creates complexity. Performance overhead. Virtual machines share the same resources of the physical computer with so many users. Sharing resources by many users automatically leads to performance degradation if they are not maintained well. Next is security risks. A compromised hypervisor or virtual machine can potentially affect other virtual machines. The virtualization environment needs strong security planning. VM sprawl. Uncontrolled creation. Sprawling means uncontrolled creation of virtual machines can complicate management and increases the possibility of security attacks. Next disadvantage is single point of failure if not high availability. A failure in single physical host can bring down all virtual machines on it. If the virtual machine is not used as a high available virtual machine, if it is not set as high availability. Virtualization technology examples. The Zen hypervisor is used to create para-virtualization. Para-virtualization is a virtualization technique that simulates physical computer into many virtual computers. Every virtual computer contains operating system, libraries and applications. The guest operating system is aware of virtualization environment in para-virtualization. That is, the guest operating system knows that it is processing as a virtual machine. So, it modifies the guest operating system as a modified guest operating system. The user application executes through virtual machine manager. The Zen-O Linux is the modified operating system that runs on Zen hypervisor. See the diagram. Hypervisor is applied on hardware to create a virtual machine. Virtual machine is now having modified guest operating system and applications. The applications run through hypervisor. While running, it runs through API, ABI and ISA, application programming interface, application binary interface and instruction set architecture. These three types of instructions forms 4 security rings. The most privileged security ring is ring 0. It is formed with Zen hypervisor software. Modified guest operating system forms ring 1, the privileged mode, and the user application instructions form the security ring 3, the least privileged mode. VMware full virtualization. VMware is a hypervisor which is used to create full virtualization. It creates virtual machines. Each virtual machine will have a guest operating system, software library and applications. The guest operating system may be any general operating system. It may be Windows or Linux or Mac OS. The virtual machine directly communicates with physical hardware to run the applications. See the diagram. VMware hypervisor is used to create virtual machines. Virtual machines contains guest operating system, software libraries and applications. To run applications, guest operating system directly communicates with physical hardware. The instructions forms API, ABI, ISA. API means Application Programming Interface, ABI means Application Binary Interface, ISA means Instruction Set Architecture. They form four security rings. VMware Hypervisor instructions forms security ring 0, the most privileged mode. The guest operating system instructions forms security ring 1, which is in privileged mode. The user application instructions forms security ring 3, which is least privileged mode. Full virtualization. Full virtualization is virtualization technique that allows multiple virtual machines to run on a single physical host without modifications to guest operating systems. In a fully virtualized environment, each virtual machine operates as if it has its own dedicated physical hardware, even though it shares resources with other virtual machines on the same host. In a full virtualization, each virtual machine contains its own guest operating system, libraries, and applications. VMware is the software which is used to convert a physical machine into multiple virtual machines. VMware is a leading company which generates the hypervisor in the field of virtualization and cloud computing. Pros of VMware: highly reliable, mature ecosystem, performance, security, management tools, live migration, wide guest operating system support. Cons of VMware: cost, resource intensive, complexity, vendor lock-in, limited free options.